All right, this is the second video on exponents. If you haven't watched the first one, it might help. So I kind of want to talk about a concept that's important to exponents. We've sort of learned about these different operations, right? We learned about addition. And we learned, as we were learning about addition, we realized, that the opposite of addition is subtraction. So for every sort of additive operation, right? Addition is adding. We have an opposite. In this case, it's subtraction. And then we learned about multiplication, which is a shorthand for addition. And we said, okay, but there's obviously going to be an opposite that sort of undoes the act of multiplying. And in that case, that was division, right? Well, there is also an opposite of exponents that does the opposite effect of an exponent, and it's called a root. And in this video, we're only talking about square roots, which means undoing the act of squaring something. So let's talk about 4 squared. Well, that means 4 times 4, right? Well, what is 4 times 4? Well, that's 16. So the opposite of that means, if I say, what is the square root of 16? Then you're saying, what times itself equals 16? Well, we just showed the 4 times 4 is 16. So the square root of 16 is 4. And we're going to talk about why it's called squaring and why it's called a square root. In class, we would draw a square out and then find the area. So let's just do that for a second. Let's draw a square. Let's say, okay, well, here's a square, badly drawn one. And let's say that the side equals 3 something, inches, feet, whatever. Well, how would we find the area? We've now taken this 3 and we've made a square out of it, right? So instead of just being 3, well, the area of a square is you multiply the length by the width, so 3 times 3, that means the area must equal 9. And hopefully we know this here, since all the sides are the same, instead of saying length times width, we could just say we square the side, right? 3 times 3. So look at another example. If I had a square and a side was 5, well, to find the area, I'm going to do 5 times 5, or I'm going to square it, right? The act of squaring it is determining the area of a square with a side of 5. And that's why it's called squared. So the inverse of this is true. If I told you, hey, I have this square and its area is 25, maybe 25 feet or whatever, then you would say, if I said, well, what's the root? And by root, I mean what's the length of one side? The size that this square was made from, its root. Then you would say, oh, well, it must be whatever times itself is 25, right? So we would say, oh, the side must be 5. Here, what's this side? Well, I know that if the area is 64, then one side must be whatever squared is 64. Well, what times what is 64? Well, hey, it's 8, so this side must be 8. So the root of this square, the square root of 64, must be 8. And so this kind of creates a pattern. And we have, I want you to understand that there's sort of this set of numbers that are whole numbers that when squared come out to be a certain value. What is 2 times 2? Well, that's 4. 9, 16, 25, 36, 49, right? 64, 81, 100. And this set of numbers are called perfect squares. And we're going to have to get these memorized. And it doesn't take long because we're going to start using these numbers a lot. These numbers become really important in math. And when we talk about irrational numbers, we'll talk about why more. But right now, I just really want you to understand that these perfect squares are really significant in nature and in math. So anyways, we need to see how these work together, right? I asked you, what is x to the 4th times, right? If it's outside the parentheses, that means times the square root of x squared. Well, let's think about this. What is the square root of x squared? I'm saying, what times itself equals x squared? Well, x, right? The square root of x squared is simply x, because x times x is x squared. So this problem becomes x to the 4th times x, which if we remember from the last video, x is x to the 1st power, right? So we have x to the 4th times x to the 1st. So that's going to equal x to the 5th. Here I say, what's y to the 3rd times y squared? Well, that's y times y times y times y times y. That's y times itself 5 times. So this equals y to the 5th equals. So that's just a little preview about square roots. There really isn't anything more to it. You just need to understand that it's the opposite of exponents, and it's just a new operation that cancels out the effect of an exponent. So anyways, I now want to talk about one other major property. We talked about multiplying numbers that have the same base that are raised to different exponents. And we said, hey, this is just 4 times itself 3 times 4 times itself 2 times. That comes out to a total of 4 times itself 5 times, right? Well, let's think about division, okay? And you may have the intuition already to say, I bet I'm supposed to subtract these exponents, because division's the opposite of multiplication. And since we're adding these exponents, I bet we're supposed to subtract these. And if that's your intuition, then congratulations, you have great intuition. But let's talk about why, okay? We're saying 4 to the third divided by 4 squared. Well, let's think about what that means. That means 4 times 4 times 4. And remember, division is fractions. Go back and watch the second video on fractions if you don't remember that. But 4 to the third divided by 4 squared is the same thing as saying 4 to the third over 4 squared. And 4 squared means 4 times 4. All right, well, here's what we have here. We have 4 divided by 4. Well, what is 4 divided by 4? Well, it's 1. It cancels out, right? And so we're multiplying that by another 4 divided by 4. Well, what is 4 divided by 4? Well, it's 1. Cancels out. So really, we have 1 times 4. Well, what does that equal? That equals 4, or 4, or 4 to the first power. And yes, we could have gotten that by saying, well, that's just 3 minus 2. That must be 4 to the first power. So this means you have 7 a's. I'm actually going to switch over to my type tool here. We've got a times a. That's 2, 3, 4, 5, 6, 7. That's 7 a's divided by 5 a's. Yeah? That's what that means. So once again, we can start canceling these out, right? This is why we subtract. Those cancel out, and those, and those, and those, and those, and I'm left with 2 a's, right? A times a, or a squared. And yeah, we could have just subtracted these exponents. What's 7 minus 5? That's 2. And in general, this tells us the quotient property. You remember when we were multiplying, it was the product property, because the solution in multiplication is a product. Well, here we're dividing, so we have the quotient property of exponents. So there's some problems we would do, and without kind of going through drawing everything out again, yeah, that's, okay, well, 9 minus 3, this must be 8 to the 6th. And I do want to point out here that once again, negative exponents just mean an inverse, right? So this is m to the negative 2, right? Because 5 minus 7 is negative 2. Well, that's the same thing as 1 over m squared. And I'd encourage you to draw this out just the way we drew these out. And try that. You'll be left with 2 m's on the bottom, right? They cancel out. All 5 cancel out, and we're left with 2 on the bottom. So this is 1 over m squared. So anyways, I would encourage you to just really play with that, write some more problems out, go to Khan Academy and practice some problems. This is really all the explanation that's needed, but it is a brand new concept, like with fractions, multiplication, you've been seeing this stuff for years, but this is the first time you're being exposed to this, so it shouldn't feel super comfortable right now. It should be a little confusing, and it should be a little like, wow, this is a whole new way of thinking about numbers and math, and that's okay. Like, support that and nourish it by going and practicing it, and try and write it out and understand it yourself, create your own problems. All of that's really critical when learning such a new skill like this. We're about to dive into scientific notation. Thank you guys very much.